In section 10.2, we're going to continue our discussions on circles, and in this particular lesson, we're going to look at finding arc measures. So something that again, I think is going to be primarily new to you. So first of all, some vocab. We got quite a bit again, as I told you in the first video of this chapter, that there's going to be a common theme. We're going to have quite a few vocab words that we're going to have to continue to talk about. So first of all, a central angle. Okay, a central angle of a circle is an angle whose vertex is the center of the circle. In other words, if this is my center point, and I draw an angle in here, all right, then this angle here would be called a central angle because, again, the vertex of that angle is the center point of the circle. All right. A minor arc is the part of a circle measuring less than 180 degrees. Okay, in other words, if I draw in a central angle here that's clearly less than 180, then this arc, okay, an arc is that part of the circle right there that I'm kind of tracing right now. That arc is called a minor arc. Okay, it's less than 180. In other words, it's less than half of the circle. Okay, a major arc is the part of the circle measuring between 180 and 360. So again, if I draw in a central angle here that's clearly less than 180, all right, then this arc would be your major arc, while this other one here would be your minor arc. Again, the blue one in this particular diagram is going to be less than 180. The green one is going to be more than 180 degrees. Okay, so just, again, some terminology that you need to be familiar with so when we're talking about these problems, it's not foreign to you. All right, a semicircle is an arc with endpoints that are the endpoints of a diameter. In other words, if you cut a circle, in other words, your central angle is 180 degrees. It wasn't very good, but you get the idea. If I cut the circle right in half, well then each arc, okay, the green one and the blue one, they're not a minor arc, they're not a major arc, so we call them a semicircle. All right, the measure of a minor arc. Pretty straightforward stuff here. The measure of a minor arc is the same as the measure of its central angle, i.e., here's the central angle. I tell you that this angle here is 120 degrees. All right, so then obviously the measure of this minor arc, the measure of that arc is also 120 degrees. All right, pretty straightforward concept. The measure of the major arc is the measure of a major arc, is the difference between 360 and the measure of the related minor arc. In other words, if I take the same diagram, if I tell you that this central angle here is 120, this minor arc is also 120, and hopefully it makes sense to you that a full circle has to be 360. So to find the blue one, the major arc, 360 minus the 120 tells us that the major arc there has to be 240 degrees. All right, and so that's the process for finding the measure of a major arc. Congruent circles, two circles are congruent if they have the same radius. So if I could do it a variety of ways, but if I tell you, if I just mark them like this, those are congruent. Those two circles have to be congruent. I could tell you that this radius is 7 and that's 7. That also tells you that they're congruent circles. So again, congruent circles have the same radius. And finally, the last vocab term here to discuss, congruent arcs. Okay, two arcs are congruent if they have the same measure and both of the circles are congruent. So in other words, if I do this and I tell you, hey, this is a 90-degree angle and this is a 90-degree angle, and I say, okay, determine whether or not the red arc is congruent to the green arc. Well, there's not quite enough information here. I do know that the measure of this arc is 90 degrees and the measure of this arc is also 90 degrees, but that's only part of it. The other part of it is I have to determine whether or not the two circles are congruent. So as of right now, I can't say anything, but as soon as I do this, okay, now you can say, oh yeah, those arcs have to be congruent because they have the same measure and the circles are congruent. Okay, so we're going to use a lot of these ideas now as we go through the notes here. All right, so the expression MAB with a little kind of part of a circle over the top is read as the measure of arc AB. So if I want an arc, all I do is I use the two letters and then I put the little guy on top. Okay, so the measure of arc AB here, since this central angle is 50, this arc measure is 50 degrees, which makes the other one 310. Okay, since again 360 minus 50. Now, one thing to note here, if we name an arc using 2 letters, generally that means that it's a minor arc, and if we use 3 letters, that means it's a major arc. Okay, so ADB means start at A, go along the circle, pass through point D, and then stop when you get to point B. All right, so that's what we mean when we say arc ADB. I'm just going to kind of... All right, so the measure of a minor arc is the measure of its central angle. We already knew that. The measure of the entire circle is 360. Already discussed that a little bit. Major arc, we know the difference between 360 and the minor arc. And then finally, the measure of a semicircle is always 180 degrees. All right, again, we cut the circle in half. Half of 360 is 180. All right, find the measure of each arc of circle C, where DF is a diameter. So DE, well, that's good because the central angle is 117, which makes this arc, I'm having trouble here, there we go, which makes that arc measure 117 degrees. DFE, again, that means, I'm going to erase here so we can kind of clarify what we're looking at now. So DFE means start at D, travel along the circle, pass through point F, and then stop at E. All right, so I'm looking for this big arc here. Well, you know, we already know that this piece here was 117. And so 360 minus 117 is going to give me the measure of my major arc. 360 minus 117 is going to be 243. So 243 degrees. I think I screwed that up. Let me see here. 240... 340, 350. No, that's right. Okay. So 243 degrees is the measure of that major arc. And then finally, DEF. All right. DEF now is this arc. Start at D, go through E, stop at F. Okay, well, they told us that DF is a diameter. So that diameter cuts our circle in half. Therefore, we know the measure of DEF without doing a whole lot of work is 180 because it's a semicircle. All right. The arc addition postulate, very similar to segment addition or angle addition, which we've already talked about earlier this year in first semester. It says this: if you want to know the measure of arc ABC, okay, so in other words, you want to know the arc, that measure there of that big arc, all you have to do is take the 2 smaller arcs and add them together. So in other words, take arc AB and add to it arc BC. All right, so you want the big arc, just take the 2 smaller ones, add them together. So it says find the measure of BD. Okay, well, here's B, here's D. Now, I don't like that because, again, how do you know if you go right or left? Well, the rule of thumb I always use, if there's 2 letters being used, it's generally going to be a minor arc. Okay, so in other words, I take 105 and 55, I add them together, and I get 160 degrees for the measure of arc BD. Okay, now BCD, you'll notice, is the other guy. Okay, in other words, BCD means start at B, travel through point C, stop at D. So you could do that a few different ways. You could either say, well, hey, that is the major arc, all right, and blue is the minor arc, so I could just take 360 minus 160, or you can just add up the 2 pieces. 140 plus 60 tells you that the arc measure has to be 200 degrees. All right, hopefully that's a pretty straightforward idea for you. That's the arc addition postulate. All right, so it says tell whether the given arcs are congruent, explain why or why not. So I look at BC and DE. BC and DE. They're in the same circle, so now the question becomes, do they have the same central angle measure? Well, this guy's 75 and that guy's 75, so yes, they are congruent. Why? Because they have the same central angle and they're in the same circle. Okay, AB and CD now. AB and CD, I can immediately say that they are not congruent. How do I know? First of all, I'll say no. And then I can say circles not congruent. Okay, circles are not congruent. FG and HJ here in this last part, FG, HJ. Okay, well, let's see. They have the same central angle, right? 90 and 90. And the circles are congruent because I see that they've put a tick mark here and a tick mark there to indicate that the radiuses are the same. Therefore, FG and HJ would be congruent. All right. So now we're going back up to example 2. I probably should have put this one right after it. It's kind of the same idea. It says find the measure of arc BCA. So BCA, a couple different ways you could do this. You could add all those up, or you could say, well, I know that this piece, okay, this piece here is 55, 360 minus 55. Either way, you're going to get to the same spot. We'll use the arc addition postulate, okay? So BCA says to take 140 and 60 and 105 and add them all together, and so you end up at 305 degrees for your arc measure. All right. Arc ABC, again, start at A, travel through B, stop at C, and so I take those two pieces, so I have 55 and I have 140. I add them together, I get 195 degrees. All right. And finally, the last problem says, in the diagram, explain whether or not, or determine whether or not PQ and SR are congruent arcs. So PQ, SR, again, it goes back to the idea of A, are the circles congruent? Well, they're in the same circle, so that's doesn't matter. Now you look at the central angle measure. This angle and this angle are the same, therefore PQ and SR are congruent, yes, because they're in the same circle, they have the same central angle measure. So my hope is that this section makes quite a bit of sense to you. It is pretty straightforward in terms of if you understand central angles and central angle measure and arc measure, then you'll be good to go. So bring any questions to class and we'll go from there.